0, first, second, right? Okay. So basically, if you drew like a first order reaction, like on a, like if you graphed how the reaction went through, like the concentration of it, basically the idea is like this. So let me just take a moment over here. So if I have like, sorry, A plus B yields C. Plus C. So if I had A plus B yields C, right? What's gonna happen to the concentration of the reactants? If I'm starting at like 2, it's gonna go down, right? Because they're being used up to go to the products, right? So if I started up here for like, let's say A and B at some concentration, these are gonna go down, and then C starts at 0 because you have nothing to begin with, right? And then it's gonna be producing, it's gonna go up, right? That's like the basic idea of kinetics, right? Now, bless you. Now, basically, with all those graphs, like first, second, third, or sorry, first, second, 0, it's like one of these being displayed, for example, A, and it just like graphs the concentration of A going down, right? But these type of graphs are really hard to like analyze because it's a curve, right? We rather have straight lines because that's what we're used to. We don't really want to mess with parabolas or any of that stuff either. So let's just try to do like a straight line, right? So basically what you end up getting is we have, so if we have like first order reactions, and they're always time on the x-axis. So if we just have any order reaction, time on the x-axis. If something, I'll explain first, second, 0 in a second, but let's say something is a 0 order reaction, and you graphed it concentration of A versus time, it will be a linear graph that will go like this. Okay, basic idea of it. Okay, now the reason why we like lines is because we all know the equation of the line, right? The equation of a line is always y equals mx plus b, right? So y is your concentration of A, x is time, t, b is the y-intercept, which is, this is concentration of A on the y-intercept, or the y-axis. So the y-intercept is like some initial concentration of A, so let's just call it A naught. That makes sense? So then we're gonna say plus A naught. And then turns out that this is a negative slope, so it's negative, and then the slope in this case equals negative k. And k is the rate constant, right? So that's the equation of a 0 order reaction, right? It just kind of derives it based on the graph, right? Now, if you try to graph that for a first order reaction, like if you try to see what it looked like, for a first order reaction, it would be like, it would look, you don't have to draw this, but it would look something like this, okay? We can't analyze that, okay? That's the basic idea. So we need to adjust it somehow, so what we do is it turns out if we natural log the concentration of A and plot those for the y-axis, like they're not concentration of A, they're natural log concentration of A. When you plot that, you're gonna end up getting a straight downward line as well. Okay, so then, again, does everybody see the y equals mx plus b here? Right, same idea over here, except you're gonna swap the a's with natural log a's. So it's gonna be natural log A as your y, negative k as your slope, t as your x, plus natural log A naught. Y equals mx plus b. Okay. Turns out same thing is for second order, we can't do shit. So we need it to be, we need to modify the y-axis, so we need to go 1 over A. Okay, when you do that, so again, this whole axis is 1 over A. This spot right here is 1 over A naught. This y-intercept here is 1 over A naught. and this is slope equals negative k. Any questions? Make sense? Okay, so then time, and now if we graph this, is actually going to be a upward slope, a positive slope, right? Different than these two, okay? So, does that make sense? So like, if he says what reaction order is this, and he gives you 3 graphs, and one of them has an upward positive slope with the y-axis 1 over a, you know that's a second order reaction, okay? Now, I'll give you some examples like which one is what's the order of the reaction, but if you got a graph like this, and it said like, is this a first, second, 0 order reaction, or what reaction order is it? It's not possible to be any reaction order, because although it's a downward slope, so you're like, I'm thinking one of these, but the y-axis is not natural log A or A. Does that make sense? So like, he won't give you a problem like that, but like, he'll probably give you 3 graphs and say which one's the right one. And don't mistake it if like, it's a downward slope. You have to make sure it's a downward slope and the axes match. That's the biggest thing. Does that make sense? Yeah? Okay, but this is gonna be upward. So then for the y-axis, it's gonna be 1 over A equals kt, positive kt, right? Because it's an upward slope, plus 1 over A naught slope equals k. Any questions so far? Okay, so now the biggest thing you need to do is when you see an order reaction, you need to write down, like when you get a problem, just underline whatever order it says it is right away, okay? Because like that's the idea, like you see, like the second you see first order, underline that and then write the equations for first order. You're gonna see me as I do the problems. So, let's see. Okay, so now let me just write a couple equations so you have a nice chart, and then let me explain what these all mean, okay? So again, there's half-life, so you should know the half-life along with all this. Half-life for, the equation for half-life for 0 order is A naught over 2k. For first order, it's half-life T1 half, that's half-life. It's gonna be 0.693 over k. And then for second order, it's going to be half-life equals 1 over k concentration of A. Sorry if you can't see. Okay, and then the other thing you should know for each one is for the units, you're going to need to get, you need to write down the units for the rate constant, okay? So you can be like me. I kind of like memorized it for the most part, and then like, but then if you have a third order reaction, you should be able to still figure out the units for that. Does that make sense? So like for the first, second, and 0 order, the units for k, which is the rate constant, are for 0 order, it's molarity per second, or like some order of that, millimolarity, micromolar, whatever it is. That makes sense. For first order, it's gonna be, so notice this is k per second. You just, for each one you go down, you're gonna divide by molarity. So this is molarity per second. First is per second, or another way to write is second inverse. That makes sense? So like, and then this one is going to be, so if this was molarity, this was second, molarity per second, this is second per second, this is going to be molarity inverse, second inverse. And then third would be molarity -2, second -1. And as you keep going, you just can add, so divide by molarity. Okay, does that make sense? Any questions on this? Okay, so couple questions for you guys. So it says if I give you something that's a first order reaction, right? And something is first order, and I double the concentration of A, that's gonna have an effect on the rate, okay? So if I double the concentration of A, if it's a first, or like, you guys know rate laws, right? So let's say this, for example, is a first order reaction. Okay, another way of saying first order reaction is if I do like A yields B. There's one thing that turns into another thing. The reactant, like there's only one molecule in the reactant side. That's what first order means. If it was second order, it would be like A plus B yields C. Like two things coming together. Does that make sense? Zero order gets a little tricky. I'm not too sure about that one, but it just means zero order just means it's like the molecule is in one of the steps, but it doesn't affect the rate determining step, which I'll talk about in a second. Okay, but basic idea is like first order is A to B, and if I double the concentration of A, how do you think that's gonna affect the rate? Double, right? First order reactions, if I double the concentration of A, it's gonna double the rate. Okay, if I triple the concentration of A, what's gonna happen? Triple, right? So, like, write that trend down. You need to know that for sure, because he's gonna test all about it. If I half the concentration of A, what's gonna happen to the rate? It's gonna be cut in half. Does that make sense? Yeah. Okay. Now for second order, if this was second order, so for example, A squared or A and B, but let's just say A squared. If this was A squared, and I double the concentration of A, what's gonna happen to the rate? 4 times, right? If I triple the concentration of A, what's gonna happen to the rate? 9. The thought process behind that is 2 is for A, double the concentration, squared, 2 squared is 4, which is gonna be quadruple the rate. If I do 3, and it's 3 squared, it's gonna be 3 squared, which is 9, so it's gonna 9-fold the rate. Does that make sense? For a zero order reaction, if I double the concentration of A, zero order means if I double or do anything to the concentration of A, it does not affect the rate at all, right? So if something is a zero order reaction, or like respective to A, for example, this is a zero order reaction. Let's say I had like A yields B, and B's not involved at all in like the reactant side. So if I ask you what is the order of B, it'll be zero order because it's not even involved. Does that make sense? Because it's not in the it's like in the product. So we're only focusing on the reactants right now, right? It's on A's in the reactant side. So technically, for this would be 2A yields B. If it's like, if this is the rate law, that means 2A yields B. The order is the coefficient. Does that make sense? So like, if I had like 2A plus B yields C, the rate law would be rate equals KA squared B. It's just like the concentration of the concentration of the reactants, and then the power, the exponent, is the coefficient of each. This is only true if this is like the slow step or the rate determining step, which I'm going to get into later. Okay? Does that make sense? Does everybody see how this translates to this? Yeah.
So do you multiply the concentration of A by 2?
Say it again.
Do you multiply the concentration of A by 2?
Well, I'm just letting you know the trend. If I keep B constant and I double the concentration of A, what's going to happen here? A is going to be squared. So if I double the concentration of A, it's going to cause the rate to double. Quadruple, sorry. If I double the concentration of A, 2 is going to be squared, making it 4. That makes sense? Okay, so if I double the concentration of a zero order reaction, for example, like for example, this is respect to like B. In this case, if I double the concentration, the rate's not going to change. If I triple the concentration, the rate's not going to change. Does that make sense? Okay.
Why is that not?
So this is the rate constant, right? Rate constant, I'll show you how to get it in a second. But rate constant is rate, the general formula is rate equals K. I'm going to like dive into this soon. But rate equals K times the reactants, and like just be like, if I had like A, B, C, I would write concentration of A, concentration of B, concentration of C, and then raise them to the power of the coefficient. So the coefficient of A is 2, so I'll raise it to the second power. For Does that make sense?
Yeah.
So then, if the product, so